Okay guys, so we had our exit slip today, and I thought maybe I'd try something a little different for the review. Instead of doing it in class, I thought I'd create this video so that then you can access it when it's convenient for you. You can pause it, you can rewind, and you can reference this as you work on any corrections using the assessment reflection correction sheet we have in class. You can submit those for half credit back, and you have until Friday, October 26th to do so. So I'm going to walk you through my thinking, just as if I'm taking this myself, starting with number 1. They're asking me to define each variable, write an equation to model the total cost. Talking to me about a situation at a frozen yogurt shop. I have $5 to spend. I have the following costs: 10 cents per ounce of yogurt. I've got 20 cents per ounce for toppings. Okay. So to me, what I'm noticing about this situation is I have a rate per ounce of yogurt. I have a rate per ounce of toppings. I'm seeing this as a standard form situation. I'm going to define X to be the number of ounces of yogurt. I'm going to define Y to be the number of ounces of toppings. And if I assemble my equation, I've got some number of ounces of yogurt, each of which costs 10 cents. I've got some number of ounces of toppings, each of which cost 20 cents. And the total I have to spend is $5. So that would be my equation. Now, when I go on to number 2, they're asking me to use that equation, and they're asking me how many ounces of toppings can I buy if I have 16 ounces of yogurt. Okay, so I'm coming up with how many ounces of toppings for 16 ounces of yogurt. Well, number of ounces of yogurt I've defined to be X. You might have called them Y, but I made a choice here. I need to follow it through. If you had these reversed, that's okay, as long as you follow through your thinking. So X is my number of ounces of yogurt, which they have now told me is 16. Okay, so I'm going to use that in my equation. 0.1 times 16 plus 0.2 times Y, whatever that is, has got to equal $5. Okay, so 0.1 times 16, that's going to move that decimal, $1.60 is what it's costing me for the yogurt, plus 0.2 times the number of ounces of toppings. I'm going to subtract $1.60 from both sides. I'll use some mental math here. 5 minus $1.60. I know 5 minus $2 would be $3, but this is $1.60, so that will be $3.40. And I'm going to divide by 0.2. I know 34 divided by 2 would be 17, so 3.4 divided by 0.2 will also be 17, and that's ounces of toppings. And of course, you had your calculator available to use, but I'm trying to model some mental math as well. Okay, so let's go to number 3. Number 3, again, we're being asked to define the variables and write an equation to model the total cost. Well, that's what I did in last one, total cost. Let's see what's going on here. We're planning to run a lemonade stand to raise money for the local Humane Society. It will cost us $25 to buy a table and jug, and 15 cents for each cup. Okay, and they're, I guess, including the cost of the paper cups and the lemonade mix in that particular estimate or cost there. So here's what I'm hearing, right? I know if I'm running a lemonade stand, $25 to buy a table and jug, well, that's a one-time cost. That, to me, sounds like a startup cost. Like when we were talking about gym memberships or dance club memberships, and I had to pay something to get going before anything else even happened. And then 15 cents for each cup. Well, that's a rate of change, 15 cents for one cup, but that's the only rate of change I'm hearing here. So I'm envisioning a y equals mx plus b slope-intercept situation, where x equals the number of cups, and y is going to be my total cost. Okay, so let's see what I have here. Y is my total cost. Well, what's my slope? That's going to be my rate of change. How much for each cup? I know x is my number of cups. How much for each cup? Well, 15 cents. Okay, 15 cents for every 1 cup. And B, my y-intercept. What happens when x is 0 before I've even purchased 1 cup? Well, it's already cost me $25 for that table and that jug. So there's my equation. Over here, now I'm going to use that equation. And they want to know what happens if I plan to sell 200 cups of lemonade. What's my total cost? Well, if I'm planning to sell 200 cups of lemonade, then I've got to buy enough cups, paper cups and lemonade mix, for 200 cups. So X, number of cups, well, 200. Now I'm going to use my equation, y equals 0.15x plus 25. We just said x is going to be 200. See if I can use some mental math here. I know if this was 100, 0.15 times 100 would be 15. So 0.15 times 200 will be 30, plus my startup cost. So I've got the total cost to buy all those 200 cups and the lemonade mix, and then I've got my cost for the table and the jug. So total cost, 30 plus 25, 55, and my units are going to be dollars. $55. Okay, let's take a look at number 5 now. So for this one, I'm writing an equation to model the total income. Same lemonade stand as in number 3 to 4, the ones that we just did. But now I'm selling the lemonade, and I'm selling it for 50 cents a cup. Okay, so they want us to model total income. That's the total amount of money that I am bringing in. We had a problem on the slope-intercept word problems homework sheet several days ago where we were talking about cost, income, and profit. So this one was very much like that. So let's see. Variables. So X, I'm going to let be, again, my number of cups. I'm selling cups of lemonade. How many cups am I selling? Y is going to be my total income. Okay, how much am I making in total for selling those cups? And I'm again hearing only one rate of change, 50 cents a cup. So this is again sounding like a slope-intercept situation, y equals mx plus b, where y is my total income. My rate of change, right? I've got X number of cups, and my rate of change, well, I'm making 50 cents per cup, 0.5. Okay, plus B. Well, then what is B? Right? Slope-intercept. B is my y-intercept. It's any startup cost or startup income when X is 0. Well, nobody's coming to my stand and just handing me money in this particular situation. I wish that they might. But in this case, I'm going to assume, nope, they're only giving me money for a cup of lemonade they buy. So B equals 0. Okay. So Y equals simply 0.5x. All right, over here. Let's see. All right, I purchased enough to sell 200 cups. That's what I hoped to sell. But interestingly, real world situation, I actually only sell 150 cups of lemonade. So what's my income? How much did I actually take in? Well, I'm going to use this equation from here. The number of cups I sold, I actually sold 150. So Y equals 0.5 times the cups I sold, 50 cents per cup. I sold 150. Well, what's half of 150? $75. There's my income. That's what I took in at this lemonade stand. Profit? Well, profit is whatever income I took in minus the cost to set up the lemonade stand. Well, my income was $75. From the other side, from number 4, my cost was $55. So my total profit is $20. And of course, that's the profit that I would then donate, a $20 donation. Okay, so the last question here, we're writing an equation to model the gas in the tank for a trip where we're traveling at a constant speed on flat terrain. After 25 miles, we have 5 gallons of gas. And after 50 miles, we have 4 gallons of gas. Okay, so I'm hearing 2 points there. 25 miles, 5 gallons. 50 miles, 4 gallons. This is like the baby calf who we knew was a certain number of pounds at 4 months or whatever it was, and a certain number of pounds at 8 months. Here we've got miles and gallons. So I'm feeling, again, slope intercept. I've got a rate of change, miles per gallon. Definition, X. All right, well, I'm going to say X is my number of miles, and Y is my number of gallons. So how do I use this information? Well, I basically have 2 points. I can label X sub 1, Y sub 1, X sub 2, Y sub 2, and I can find my slope. And I find -1 over 25. For each mile traveled, for each gallon of gas, I'm able to go 25 miles. Okay, so how do I use that? Well, there's my slope. How do I find B? Well, I have 2 solutions to this equation. I can input one of them, and it doesn't matter which one. I'm going to choose the smallest. And I get 5 equals -125 times my X plus B. I know 25 is the same as 25 over 1. And I notice these are going to cancel out. I either get -25 over 25 or I cancel these out. Either way, I get -1. And when I add 1 to both sides, I find my B value is 6. So when I assemble, Y equals -1/25, X plus 6 is my equation. So how do I use it? Well, how many gallons of gas were in the tank before I started the trip? Well, that's where X equals 0. When X equals 0, I had exactly 6 gallons of gas in the tank. That's my Y-intercept. Right? At 0 miles, I had 6 gallons. Okay. How many gallons would still be in the tank after 100 miles? Well, they're giving me a value of X. So I've got Y equals -125 times 100 plus B. That's the same as 100 over 1. I get Y equals -100 over, and that's a 6, my apologies. Okay. Over 25 plus 6. -100 divided by 25 is just -4 plus 6. So 2 gallons I would have left after 100 miles. Okay. And then lastly, from the start of the trip, how many miles can I travel before I run out of gas? Well, this is interesting because now they're giving me a run out of gas scenario. That's Y equals 0. That would be where I have 0 gallons. What would X equal? Well, let's use our equation, but this time I'm putting 0 in for Y, and I'm solving for X. Okay. So we'll go ahead and do the math. -6 equals, that's gone, -125X. I can multiply by the reciprocal to get rid of that there. So I have X equals -6 times -25 over 1. That's just -6 times -25. That's going to give me 150. Negative times a negative is positive. So I can travel 150 miles before I run out of gas.